All right, hello once again, Jeff Scott of Rankin Technical College. I've been going through the PowerPoint presentations for Tony Gaddis's starting out with Java Early Objects 5th edition. We're up to Chapter 10 of 16, which is on exceptions and advanced file I/O. I must tell you that I'm currently producing the Chapter 9 lecture, so while I'm lecturing in here, at some time or other, the screen's going to look a little funky and I'll have to spend about 30 seconds or so cleaning it up, just so you're aware of that. So, our topics: handling exceptions, throwing exceptions. That's most of the chapter. So there's also a little hodgepodge in here, so we also talk about binary files, random access files, and object serialization. That's the advanced file I/O stuff. I mentioned in an earlier chapter, and I'm saying it again, that an exception is an error condition or some kind of an unexpected event. Exceptions are thrown. It is the programmer's responsibility to write code that will handle an exception. And if the programmer does not do that, typically the program will crash. If the programmer does not handle the exception, typically the program will crash. Java allows you to create your own exception handlers and call existing exception handlers. An exception handler, then, is a section of code that attempts to respond to an exception. What you'll see in just a little bit is, like many programming languages, what Java does is it uses what's called a try-catch mechanism. All right, we'll get to what that is in just a couple minutes. So an exception is an object. Exception objects, as it says, are created from classes in the Java API hierarchy of exception classes. What does that all mean? Well, again, I've done this for you before. I'm again going to go out to java.sun.com, and I'm going to again choose Java APIs once I get out here, grab the newest, and I'm going to look down here for exceptions. Take a little bit to find the E's, right near the end of the E's, right before the F's, I guess. Exception, right there. So when you look here, here are all of the kind of pre-built different kinds of exceptions that are available to you. And if you can't find one there that floats your boat, you can write your own exception handlers. And I believe that's discussed in the chapter also. All exception classes in the hierarchy are derived from what's called the throwable class, including error and including exception. There's going to be, I think they're going to show you a picture that might help a little bit, and it also might confuse you a little more, but we'll talk about it in just a minute. Classes that are derived from error, okay, typically you have no control over. If they typically result from a software problem. So if there is an internal error in the Java virtual machine, or if you're out of memory, there's not much you as a programmer can do about that. You as an application programmer should not try to handle that. It's a more serious condition than something you can fix. You should only worry about handling exceptions that are instances of classes derived from the exception class. So everything that's over here with error, just forget about it. We care about all the stuff that's in here. And there are a lot of different kinds of exceptions. As you move down the hierarchy, exception is the most general. I/O exception has different kinds, like an EOF or an end of file exception, a file not found exception. So as you work your way down the hierarchy, the exceptions get more specialized. As you work your way up the hierarchy, the exceptions get more general in nature. So to handle an exception, you use what's called a try statement. And inside of that try statement, typically it's called a try block. But everything that's in those curly braces between the word try and the curly braces that's code that you put in. It can be as many or as few lines as you want, but it's code that could potentially fail. If it fails, the system looks for a corresponding catch. Now, there's only one catch shown here, but you can have as many catch statements as you want. But they have to go from the most specific to the most general. So as it says, try indicates a block of code will be attempted, known as the try block. The try block, again, is one or more statements that you try to execute, but they could potentially be problematic or throw an exception. If the application throws an exception, it will not halt if but the system will. Well, I don't like the way the author puts that. The application will not halt if the try block throws an exception. Technically, what will happen is control will go from the try block, and the system will try to find an exception that handles it. All right, and it'll look throughout the hierarchy, and we'll get into that in just a minute. And if it can't find anything, then typically it'll blow. The program will crash. So after the try block, you put in a catch block. The catch begins with the keyword catch, followed by the type of exception you're trying to catch. The code that follows the catch is known as the catch block. The catch block is executed only if the try block throws an exception. So in the example that we see on the screen right here, if these two statements in the try block both succeed, you skip the statement in the catch block. If either of the statements in the try block, either of those two statements fail, you immediately jump to the catch block and do that statement. As said, or as I mentioned, if you can have several of these exceptions, they must all be different, of course, but the JVM or Java Virtual Machine, once an exception is thrown, searches for a catch clause that can deal with the exception. So the parameter must be of the type compatible with the thrown exceptions type. After an exception, the program continues execution right past the catch block. Each exception object has a special method in it, and this is shown in the book, that's called getMessage, and you can use that to grab information about the error that was thrown. Polymorphic references to exceptions, as mentioned here. When handling exceptions, you can use a polymorphic reference as a parameter in a catch clause. Most exceptions are derived from the exception class. A catch clause that uses a parameter variable of the exception type is capable of catching any exception derived from the class. So in other words, right there, that catch is as generic as it gets. That's the most generic exception that you get. That's at the top of the food chain. Remember when we showed this way at the beginning. Notice the first one there was exception. That's the one that we're attempting to throw. That's the one that we're attempting to throw. Where are we? Right here. All right. If you've got multiple exceptions, what happens is, if an exception is thrown, the system looks for a catch block that can handle it. As soon as it finds one that can handle it, it skips the rest. If it goes through all of the catch blocks that are there and none of them will handle that exception, then it goes and it jumps up and it says, okay, well maybe the method that called this method has got an exception, it got a catch block in it. And it keeps going up what's called the call stack for that. It keeps looking for an exception that can handle it. If it finds an exception somewhere in the program that can handle it, it handles it. All right? And if it doesn't find one, it'll eventually crash the program because it'll error out. Now, if you look right here, this would be an error because we have the same thing, number format exception, is in here twice. You can't do that. You can only list exceptions once. And if we look at this, All right, whoops, this is what I told you was going to come up, so let me... And as I told you, it'd be about 30 seconds, so... All right. It says here the number format class is derived from the illegal exception class. So number format is more specific than illegal exception. So this one has to come before this one. Remember, you've got to put your more specific ones, more specific catches before your more general ones. So if we flip these two things around, so it looked like this, it would be okay. But like this, it's not okay. All right. Also, if you want to, need to, you can put a finally block after your last catch statement. The finally block must appear after all of the catches, and it's typically used for housekeeping. What I mean is for closing files, closing database connections, etc. The finally block executes if the exception occurs or if the exception doesn't occur. So in here, if everything in this try block succeeds and you skip that, it still does the finally. If something in here throws an exception and you do this, it still does the finally. So the finally is done regardless. Now I mentioned stack trace before, and the author is going to talk about it a little bit. Good, bad, or indifferent, you're going to get the chance to see stack traces in action, because when you start to write Java programs and you get error messages, typically what happens and what you get on the screen in like a DOS or a command prompt window is a stack trace, because the stack trace tells you what method was executing when the exception occurred and all the methods that were called before that method. All right. Now we already mentioned this, that when an exception is thrown, you can't ignore it, because if you do, the program will eventually crash. So either you must handle it in the program, or there must be some way that the system itself can handle it. So again, when an exception is thrown, the execution of the method stops, and the Java virtual machine starts searching for a compatible exception handler in that method. If it doesn't find one, it goes up the call stack to look in the method that called that method. If it doesn't find it there, it looks in the method that called that method, etc. If it gets all the way up to main, either main must handle the exception or the program will error out and crash. All right. There are two major types of exceptions, those being unchecked exceptions and checked exceptions. Notice unchecked exceptions are those that are derived from the error class. Remember, exceptions that are derived from error are critical errors that you cannot handle. All right? They're over and above your pay grade, your control, whatever you want to call it. You can typically avoid these kinds of exceptions if you write good code. There is so much code that's out there today in the world, period, that is written in a sloppy manner. It's almost incredible. All right? If the code in a method can possibly throw an exception, it must either be handled or it must have a throws clause. What does that mean? Well, you may or may not remember, we talked about this earlier in file handling, where we did something like this, and this won't compile. Because right here where we have this, since we're working with a file here, we have to say public void display file string name, but before the curly, we have to say throws IO exception, or file not found, or some kind of an exception. And notice the plural there, it's throws with an S on the end. Later, we'll talk about creating your own exceptions. The programmer will throw an exception, singular, ending with W. Java throws an exception, plural, with an S on the end. So throw is a key word, and so is throws in Java. As it says, you can write code that throws a standard Java exception or an exception that you create. So you can create your own exceptions. Again, you, Java, throws them, you throw them. plural versus singular. When you write your own exception, you have control over what the exception says and what the exception does. So this next section here is going to talk about creating your own exception classes. Now think about this. What they're going to talk about is a bank account. And ideally, most exception handling stuff is never even going to get executed. In some ways, exception handling, in some ways, it's kind of like car insurance. You buy car insurance hoping and praying that you'll never have to use it, but if you need it, you might need it bad. In much the same way, when you work with exception handling, you quite often write your catch blocks, etc., hoping against hope that you'll never need them, but if you do, you might need them bad. So this bank account.java, we're going to write our own user exception in there to handle it in case somebody accidentally puts in a negative starting balance. Here are some examples of exceptions that could occur. Notice in the first 4 cases, they're all negative numbers. You can't have a negative starting balance or a negative interest rate. You can't pass a negative number into a deposit or a withdrawal method. You also, the way this is set up, you can never have overdraws. All right, so you can't exceed any withdrawal cannot exceed the current account balance. So you can create exceptions for each one of those. All right, and again, that's shown in the chapter. If we have time, we'll go through an example of that when we go through some of the code later. Again, I have no idea how long these programs are going to take, etc. All right, we talked in an earlier chapter about binary files as opposed to text files. So we mentioned that text files could be read by an editor. In fact, this might have even been the C# class I said this lecture. I don't remember. But just in case, if I try to open up this PowerPoint file, okay, right here, if I try to open it up, just in case I didn't talk about it before, because I don't really remember, but if I try to find that PowerPoint file, which I have in here, and here, and here. So if I try to open up that Chapter 10 file, if I double click on it now, it'll open it up in Microsoft PowerPoint. But if I right mouse click on it and choose Edit with Notepad, I'm trying to open up a binary file using a text editor. And you can see the problem with it. Okay, it doesn't work. I can go the other way around. So let me close this. In fact, let me close all of these. I got a bunch of stuff in here. I was working with my daughter's boyfriend. So, all right. As we work in here then, what if I went the other way around? So in other words, let's create a real simple text file. All right, so here's a text document. There it is. We'll call it simple file .text. All right, and I'm just going to say this is an example of a very simple text file. Okay, I'm going to save it and I'm going to close it. All right, now I'm going to attempt to open up that file, but I'm going to attempt to open it up with, and I'm going to choose my own app to open it up. And I'm going to say, let's see, let's look in here. Let's look. No, I don't want to look for an app in the App Store. We'll do it this way. All right, you see what the file looks like, or like right there. I'm going to open up Word, Microsoft Word, which is designed to read binary files. But what I'm going to do is I'm going to say File, Open, and I'm going to go over to the desktop, and I'm going to find that file. So I got to find all files in here. So I want to find the file, simple file. And notice I can open that up. So I can open up a text file in a binary file editor, but I cannot open up a binary file in a text file editor and be able to do anything with it at least. All right. So if the file can be read with a simple text editor, it's a text file. If it cannot, it's typically then going to be a binary file. And as it mentions, a binary file is a file that stores binary data. It's not human readable. all right, data by default. You can read it, a human can read it if they open it up in a binary file editor. So as it says, binary files, I mean, technically you can open them, they just look like garbage. You can't read them. All right. To write data to a binary file, you have to use the Java file output stream, data output stream. And you do something that looks like this. As mentioned, a data output stream is wrapped around a file output stream. Looks kind of ugly. To write data to a binary file. We'll hopefully have time to look at an example of something like this. You can combine them together. Again, it looks ugly, but it does the job. If you want to open up a binary file for input, you wrap it around a file input stream, where previously, to write it, we were doing a file output stream. As mentioned here, the input stream will throw a file not found exception if you try to open up a non-existent file. You don't have to worry about it with output, because if it doesn't exist, it'll create it. All right. Java does allow you to work with binary files, and there's some stuff in here that goes through it, and they have you literally create a simple file as a binary file. And typically text files have a .txt extension, but they create this myinfo.dat, so it's a binary file, and then they show how you can write it as a binary file and then read it as a binary file. So I'll leave that to you to read if you have an interest in doing so. Random access files, again, I've given this talk before. It might have been in this class, but I believe it was in the C# class. Back in the day, and I know I'm dating myself here, we used cassette tapes. And with cassette tapes, we if we wanted to listen to song 8, we had to either fast forward to song 8 or listen to the first 7 songs. Then came CDs, and you could push a button and go right to number 8. All right? Pushing a button to go right to number 8, or being able to jump right to where you want to, is like a random access file. With sequential access, that's more like using a cassette. When you first open the file, the data is read from the beginning, and it continues, and it advances sequentially one at a time. In many circumstances, like payroll applications, etc., for things like that, sequential file access is all you'll ever need. But as mentioned on the very bottom of this slide, if a file is very large and you want to just look for one piece of data in it, it can take a long time to have to read through everything, especially if it's at the end. So Java allows you to perform random file access, where you can jump immediately to any location in the file. Notice when you do this, you say, I want to open it for, the mode. R for means I want to make it read only. RW means read write, etc. Again, items in a sequential access file must be accessed one after the other. The problem with a sequential access file is, imagine I've got a file with 1,000 records in it, okay? And record 500 has been corrupted. Then what I have to do is I have to open the file, write the first 499 records to a new file, fix that record that was bad, write that to the new file, and then write the last 500 records to a new file. You can't do what's called updating in place. In other words, just jump right to the record you want, make a change, and boom, you're done. You cannot do that with sequential file access. You can do that with random file access, because as mentioned here, they can be accessed in any order. The random access file class, as mentioned here, treats a file as a stream of bytes that start at 0. And there's all sorts of things that you can do with it. You have what's called a file pointer that tells you where you currently are in the file. When you first open it, the file pointer is set to 0, meaning you're at the beginning of the file. Every record in a random access file must be the same size, regardless of what it contains. So imagine that imagine you had a bunch of people's names, and let's say the biggest first name had 20 characters and the biggest last name had 20 characters. Then each record full of names would have to be 20 characters for the first name and 20 characters for the last name. You need that because the system needs to know if it wants to jump to a certain record. It needs all the records to be the same size so it can figure out an offset to figure out where it wants to jump to. So if each record is 20 bytes in length and I want to jump to record 40, I can multiply 40 by 20 and go out to location 800. That kind of an idea. Again, this is pretty heavy stuff, talking about working with random access files. The last thing that's discussed in here in the last, 4 or 5, and again, if I do enough of these lectures, I get confused as to whether I've talked about this or not, but I'm going to mention it again anyway, even if I already have. And that is the concept of serialization and deserialization. All right? If you imagine that you could take a house that was made out of bricks apart brick by brick because you were going to move it, for example. All right? Taking the house apart brick by brick would be deserializing the house. Moving to another location and putting it back together again brick by brick would be serializing the house. And that's what they talk about right here. For an object to be serialized, it must implement the serializable interface. And in the book, I believe at least, they show you an example of that. All right? That's pretty much it for this chapter. When I come back next, I'll be going through Chapter 11. In Chapter 11, as you can see on here, the next 2 chapters are going to be on GUIs, or Graphical User Interface. We'll talk about Part 1, then we'll go into Part 2. All right? Okay, and that's basically all I have for this lecture.